Welcome to BKW Physics. I'm Mr. McConley, and we're going to do some wave interference and wave superposition today. When waves interfere, they superimpose upon one another. The two words are related, but let me back up. If you have a wave, actually let's just use a pulse, which makes it simpler. If you have two pulses, and these two pulses happen to be heading towards each other, I tried to make them equal so that they look the same. I don't know if they do to you. If you have two pulses going towards each other, then eventually they are going to be superimposed, or in other words, they're going to be at the same position at the same time, overlapping on top of one another. What will that look like? Well, what it's going to look like, actually, is it's going to be whatever the height is of the number 1, plus whatever the height is of the number 2, or in other words, about, for my picture, about that height. And this is the part where it's superimposed. The superposition part. But there's still part of the wave going this way, and there's still part of the wave going that way. It just like glommed together for a second. So a moment after this happens, the wave will recreate itself as two separate waves again, except now number 2 will be over here going this way, and number 1 will be over here going this way. They'll be heading apart from one another. So they pass right through each other, and what's neat about waves is when they are superimposed on one another, they do affect one another, and it turns out to be a different shape sometimes. But after they pass one another, they go back to their identical original shape. And that's what's weird about a wave. That's interference. Now there's two types of interference. The one I've drawn right here, where two things add up to something bigger, this type is called constructive. Constructive interference. Well, then you can imagine the other type, if I draw a real quick sketch of it. So you got 1 and 2, and they're going towards one another. What's going to happen when those two, if those are identically shaped, identically sized, when they meet in the middle, here, 1 plus 2 is going to give you nothing for a minute. And then out of the nothingness, a moment later, this is where it gets kind of strange, a moment later out of the nothingness, those are supposed to be the same size, just getting low on the board for me. You're going to get number 1 continuing on, and number 2 continuing on, and they're back to their original shapes as if they just recreated themselves out of a nothing. Because energy can't be created or destroyed. And it's not. It's just changing shape for a minute, the wave, and then it'll go back to its original shape. So that's constructive and destructive interference. Now, where it gets a little odd, I guess, is, let me draw one more picture before I get to this graphic picture. If you take, for example, two pulses that are not of the same shape, like this and this. And yes, you can have squared off waves. There's sawtooth waves, squared waves. These usually occur in electrons. More on that later. Now when these two waves go to superimpose or cross over one another, what do you think it's going to end up giving you? Well, the way you have to envision it in your mind is that which one's the bigger one? Which one has more surface area? The squared off one. Okay? Assuming these are exactly the same height, I tried to make them the same height. Assuming they're exactly the same height, this one covers more square footage than that one does. So the way I envision it is that this one right here is going to take this part out. You know what I'm saying? It's going to remove that part. So when they're overlapped on one another, you'll actually get something that looks like this, which is like the squared off wave with the rounded wave part removed from it. This is the combination of these two when they are superimposed upon one another. It's going to leave you with a very odd shape. Now this is what happens in digital music all the time. There's effects called clipping, and there's like beats. And these are all things, some of them are desirable and some of them aren't desirable. But basically when you start overlapping waves and you start getting weird patterns, you start getting weird noises. And when you start overlapping the waves in certain orientations, you start getting sounds that go like whoa, 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 whoa on the music. And sometimes they want that, but a lot of times they don't. It's just an effect they're trying to avoid. Let's move over here to a real superposition example to wrap this up. Now, what I have here is I've drawn one pulse in red, and I've drawn another wave in blue. And I'm saying, what if you take this picture right now and say, what would it look like if these two waves were right here at the same time, at the same place? How would they combine? And here's the method by which you do it. Let's look at the red wave. If you look at this as being like a 0, and you think of these as positives, and you think of these as negatives, okay, just because I laid it out on a grid so you can kind of visualize it, then how high above the 0 is this? We'll call it a positive 1. What's this point right here? Positive 2. Are you kind of with me when I'm doing? I'm counting from here up. Yes? This would be 0, this would be 0. Fine. Looking down here, we could call this one a negative 1, a negative 2, a negative 1, a 0, a negative 1, a negative 2, so on and so forth. Well, now all you got to do is you take each vertical line and you see what the outcome is. A 0 and a 0 gives you a 0. A positive 1 and a negative 1 gives you a 0. A negative 2 and like a positive 1.5 is going to give you somewhere right down here a little bit, right? Give or take. How about a negative 1 and a positive 2? Positive 1. 0 and whatever that is whatever that is. 1 and 1, cancel, boom. So what I'm end up with, if you follow this, I'll kind of make it dark so you can see it real well. The superimposed wave pattern is that black dark line that I drew. That's when those two waves combine at the same time at the same place. We have a worksheet on that for the people in class for today, physics.